Hi, question number 7. Box A contains 5 red paper clips and 1 white paper clip. Box B contains 7 red paper clips and 2 white paper clips. One paper clip is taken at random from box A and transferred to box B. One paper clip is then taken at random from box B. Find the probability of taking both a white paper clip from box A and a red paper clip from box B. Second part, find the probability that the paperclip taken from box B is red. Part 3, find the probability that the paperclip taken from box A was red given that the paperclip taken from box B is red. Fourth part, the random variable x denotes the number of times that a red paperclip is taken. Draw up a table to show the probability distribution of x. Now here's the situation. We've got 2 bags A and B, 5 red paper clips, 1 white paper clip in the bag A, and then in bag B 7 red paper clips and 2 white paper clips. We're told that 1 paper clip is transferred from bag A into bag B. So I'd rather draw a probability tree diagram to be able to understand the situation better and answer the questions. And as it is, we've got 5 over 6 total in bag A. This is bag A. Now if one paper clip is transferred from this bag into this bag, let us say now that the paper clip was a red paper clip, so we're going to take 1 from here and add 1 to 7. So we're going to add 1 here to 7, and so that's going to make it 7 plus 1 is 8. So we have 8 over 10, because there was 7 plus 2, the total was 9, so we add the 1 now, it's going to become 10. And of course we still have the 2 white paper clips in that bag B, so that's going to be 2 over 10. Now suppose the one that was taken was a white one, so white is taken here and we have 2 white paper clips, so 2 plus 1 is then 3, so that's going to become 3 over 10. And as for the red paper clips in bag B, it's still going to be 7, but then the total is 10. Now we want to find out the probability that of taking both a white paper clip from box A and a red paper clip from box B. So probability of a white paper clip from box A and then times the probability of a red paper clip from box B. So we got white and then red, so that's going to be 1 over 6 times 7 over 10, so our answer turns out to be 7 over 60. So this is part A of the question. Now in the second part of the question, we want to find the probability that the paper clip taken from box B is red. So how are we going to do this? Right. So if it's red from box B, we can take a red from A, red from B, or a white from A and then a red from B. So we're going to take probability of red, okay, from A and then B from, then red from bag B. Or we could be taking white from A and also red from B. So then if we do this, we are going to get this times this, that is 5 over 6 times 8 over 10, either or plus, that means exclusive events, 1 over 6 times 3 over 10. So this is 40, okay, over 60 plus 3 over 60. No, I mean 7 over 10 here, because there's 7 over 10, so that's going to be 7 over 60. So the answer to that question is then 47 over 60. So that's the second part of the question. So now we have conditional probability. To find the probability that the paper clip taken from box A was red, given that the paper clip taken from box B is red. So let me just push this a little bit up here. Right. Now for conditional probability, we're going to be using this. Red taken from A, given that red was also taken from B. So probability of red from A, okay, times probability of red from B, given that it is a red one taken from B. So let us see now. Red from A, red from B. So red from A, red from B. So that's 5/6 times 8/10. So we got then 5/6 times 8/10 divided by, it was taken from B, right? It was taken from box B and it was red. So this is it. From the second part, we have 47/60. So let us do this multiplication here, and I'm going to get 40 divided by 60 divided by 47/60, and the 60 and 60 can go, and I have 40/47. So that's my conditional probability for the third part. For the third part, we are given that the random variable x denotes number of times a red paper clip is taken. We need to draw a probability distribution table. Now, how many times can we take a red paper clip? Okay, so we may have 0 paper clip. We may have, 0 red paper clip, which means that's going to be 2 white paper clips. And we may also have 1 red paper clip. Okay, and we may also have 2 red paper clip. And if we were to do this one here, the probability of taking both white paper clip from the probability tree diagram, we got white's going to be 1/6 times 3/10. So we got then this as 1/6 times 3/10. What's the probability of getting one red paper clip? So probability of 1 red paper clip is going to be either red from A times white from B from the tree diagram, or we can say white from A, okay, probability taking a white from box A times the probability of a red from box B. And so if I were to do this, I'm going to have to look at the tree diagram. And again, we're going to take 1 red and then 1 white. So red, white, white, red. So that's 5/6 times 2/10. Okay, and then 1/6 times 7/10. So let us see. And so this is going to be 47/60 when we do this multiplication. Now we want 2 red paper clips. Okay, so we're going to take 2 red paper clips. So that's going to be PR and R. So 1 from A and 1 from B. And from A we have 5/6. And from B we've got, sorry, a slight mistake was made here. That shouldn't have been 8/10, because we're looking for 1 white, 1 red. So that's going to be red, white, and then white, red. So red, white, okay, red, white is 5/6 times 2/10 instead of 8/10. So that's going to be 2/10. So this makes it then, instead of 47, I'm going to get 17/60. Yeah, sorry about that. So here we go. And then for the 2 red, I'm going to get 5/6 and then 8/10 from the tree diagram, which makes it 40/60. Now, if I were to draw my probability distribution table, that's going to be very easy. I have 0, 1, and then 2. X and probability of X. This one we got 3/60. 6 times 10 is 60. Then I've got 17/60. And finally, I've got 40/60. And you can check this out by adding up. If you were to add these up, you should be able to get 60 over 60, which is 1. Okay, take care.